Okay, so in this video we will solve the question number 8. In the question number 8, basically we have a data set of basically 5 students, and they have given another student data with two features. Each of the students have two features or two attributes with them, and they want us to find the similarity using Euclidean Manhattan supremum and cosine similarity, and then normalizing the values and again finding it with the Euclidean distance. So basically they want us to find the similarity between all the S1, S2, S3, S4, S5 with X. So okay, so in this question we need to the data of two students student faculty similarity analysis has been given, and there is a sample database, a data set of two attributes. The faculty responsiveness and infrastructure support is given with 5 students, and A1, A2 are the attributes. Another random outside student comes up and he gives its data, which is 1.4 and 1.6, and what we want and what the question actually wants from us is to calculate and rank all these current students with the outer student which they have provided in the question using distance formula like Euclidean Manhattan supremum and cosine similarity. And after that, normalize the student vectors and again compute the Euclidean distance, right? So to do this, I have created a small HTML page so that the question moves quite fast. The original data set here is the student, and all the 5 students and the data has been given. So at first we have interpreted the features for each student in a tuple manner, and we have a query vector which they have given us inside the question for a student who comes in this data set. So to find the Euclidean distance, what we basically do at first, basically the Euclidean distance formula is basically the x1 minus x2 whole square plus y1 minus y2 whole square root, where x1 will be the new student or an older student. X1, y1 data could be the data for new students or an older student, or it could be the newer student, right? So you can, if you will just plug in the data inside it like we have done here, like 1.4 minus 1.5, so 1.1 basically the new vector data minus the old vector which is S1, and similarly if we solve this data and taking the root of it, we will usually get 1.1414 and approximate kind of this value, right? And we'll do this for all the S1, S2, S3, S4, S5, and after ranking those, we have a ranking of S1, S4, S3, S5 and S2, right? It means this basically tells that the foreign student is kind of similar, much more similar to S1 because its distance is very less than X, right? And all the others are kind of far away from it. Similarly, this thing will happen in the Manhattan distance. So the formula for Manhattan is basically the summation of modulus of X minus Y. So in this, the X is the data for new vector minus the data for the old vector, right? So basically this is how the things happen, and in this you can just do it like this, that for the, let's just say if we take the S1, So the S1 is 1.5, so it will be kind of like this: 1.5 minus 1.4 modulus plus 1.7 minus 1.6 modulus. So if we solve it further, it will be kind of 0.1 plus 0.1, and we'll get an initial value. We'll solve this for all the 5 students, and eventually we get those values. Here again we comes to the conclusion that S1 is kind of much more closer to X, right? It's a kind of a same like the Euclidean distance, right? Next comes the Chebyshev distance, right? So it's basically like saying that, hey, just give me the maximum value which you get from X or Y. So here X and Y are X1 minus X2 is equal to X, and Y1 minus Y2 is equal to Y. So basically, whichever attributes difference is maximum, give me that one, right? So here, if we take the difference of it, it will come 0.1, 0.6, and so on, so on. Here we can see that it is kind of stumbling around S3, S4, and S5, S2 because the values are kind of same. But still, we got one really good answer, is that S1 is very closer to the foreign student attributes, right? So yes, the supremum distance is also giving us some kind of a same answer like the other two distance functions given to us. Next is the cosine similarity. So basically cosine similarity, what we do in this is that we treat these attributes as vectors, right? So if we treat these attributes as vector, what happens is that, let's just say I have one vector x is equal to something, something value, let's just say 1, 2, and I have another vector, another student, let's just say it is s something 1 and s2 something 2. These are not actual values inside the question, but for example's sake I am taking these, and another student is 3, 4, right? So you want to find the cosine similarity. Cosine similarity, basically how much angle, cosine angle they have between them. Like if it's a very less value, cos value very less, then they are very similar. If they are very high, then it's not similar. So basically what happens inside this is that we take x dot y as a dot product and the normal value of x and y. Right? So here x dot y, basically 1, 3 plus 4 2s are 8, and it will be root of 5 and root of 16, 3 3s are 9, it will be 25. So 8 plus 6, 11, root 5 times 5. Basically this is the value. If you get the angle with something, you will get something value like this. And we did the same thing inside our question too. In this we taken out all the values just like we have did in the example, and we got a very precise values, like at the level of decimal place of third we are getting some differences, other than it is just exact values. So here also the ranking kind of stumbles, because here we can clearly see that the S1 and S3 kind of like very close to each other, but here also the ranking is kind of bad. Here the S1 will be the first and then S3 will come. But eventually here we can see that S1 still is kind of much more similar to the question, right? And inside the final summary table we can see that most of the time S1 dominates, right? Means the S1 is very close, its attributes are very similar to the foreign student, right? The same thing you can do by normalizing the values, taking the mean, taking the variance, taking the standard deviation, normalize them, put them in between the -1 and 1 values, and then again solving the Euclidean distance. It's the same thing happening here, just you have to normalize those values and the answer will be the same. The S1 will again be very, very close to the foreign student, right? So this was all for question number 8. Thank you.